Okay, so there's a lot of stuff which, people who haven't really done a lot of work in physics and mathematics struggle to understand when they hear other people talk about it. So one such thing is something called a Lagrangian, something called the principle of least action, what action actually means. And I've suffered myself because I used to be really interested in physics even in like lower classes when I was in 8th and ninth, and I always heard these words: Lagrangian, Hamiltonian, action, least action, and it went over my head. So I could never understand what it actually meant. So today I thought of making a small video on the principle of least action, what action is, what Lagrangian is, and yeah, let's get started. So if I have this ball, it's a cricket ball, and if I throw it like this, if I throw it, it follows a parabolic path, right? It's going from here to there in a parabolic path. And let's say I start, this ball has some mass. I'm throwing it with some velocity. It attains some height. And yeah, it takes some amount of time. Let's call that time. Like, let's say it starts at T1, ends at T2. Now, whenever I throw it, at each point of its travel, this ball will have some potential energy and some kinetic energy, right? So the kinetic energy will be half mv squared and the potential energy will be mgh. So where m is the mass, g is the gravitational acceleration, which is 9.8 meters per second, and h is the height. Now half mv squared again is m is the mass, v is the velocity of the ball. Now if we want to talk in terms of Lagrangians, a Lagrangian is just a fancy way of saying the kinetic energy minus the potential energy. That's it. So whenever I throw this ball, at each point of the path, that it's half mv squared minus mgh. That is the Lagrangian. So let's call that L. So a Lagrangian is normally denoted by the letter L. A cursive L, a cursive capital L, L. So now we know what a Lagrangian is. What about action? So as we said, it takes some time to go from here to here, T1 to T2. If we integrate the Lagrangian from T1 to T2, that the quantity which you get after integration is called action, S. So in physics, we denote action with the capital letter S. So S is again the integral of the Lagrangian with limits of the time taken in the path, like whatever path it may be. So now you know what action is. Now what is the principle of least action? Okay, to understand that, let's first think of the ball again. When I throw it like this, why does it always follow a parabolic path? Why doesn't it go like this, a spirally wavy path? Why doesn't it go like this and come up again? Well, it's because nature always wants to minimize this quantity called action. So it always wants the least action. And because nature likes that, the least action is always produced in a parabolic path in a gravitational field. And that's why objects always travel in a parabolic path whenever under free fall, or whenever you've thrown it and they're falling under gravity. So we've covered Lagrangians, we've covered action and the principle of least action. Again, reiterating, the principle of least action says that whenever you want to throw a body in any field, in any potential field, we have taken gravitational potential, but it can be any potential. Nature always wants to minimize the action. And that's the principle of least action. Thank you.